Hello, hello, welcome everyone.
Hello, hello.
To another MSI Insider live stream. And I'm not alone here. I'm together with the one and only
Ruud.
Welcome, Ruud. Yeah, I think familiar face for a lot of people. And for most people in the chat, I think if you know Ruud is here, then you know what we're gonna do.
Benchmarking.
Benchmarking and a technical topic.
Yeah.
We're gonna talk about CPUs, BIOS, how to set your BIOS in order to run your CPU properly. We will also talk briefly about the new 3D Mark version, and we will also demonstrate it to you. We have some comparison data with different graphics cards as well. If you have any questions in the meanwhile, feel free to drop them in the chat. By the way, I see that I put the wrong background here. Let me fix that, because we also have a giveaway. Let me see. That one. That's better. We have a giveaway in which we'll give away several Steam wallet codes. You can go to msi.com/2/insider to participate, or if you're watching on Twitch or YouTube, you can also follow the direct link that our bot will put in the chat once every 5 minutes. It will each Gleam. Within Gleam you can perform certain actions. The more actions you perform, the better chance you'll have to win. And if you're a returning visitor, also make sure to claim your loyalty bonus to have a slight edge in the giveaway. I already see a question in the chat. Edwin K is asking how to undervolt Intel CPU mildly. Well, actually we do have an Intel system here right now, so later on we can also briefly talk about that.
That's a good topic, undervolt.
Yeah, undervolting is definitely a good topic, and something else that we would like to talk about, it has to do with Intel voltages, power limits, because it's been a lot in the news lately. Mostly the higher end CPUs from Intel, so the 14900K Core i9, but also the Core i9 13900K, and both of the KS SKUs as well. Yep. So those are the even higher clock ones. With certain settings, some people experienced stability issues, others didn't. The system that we have here today by default doesn't have any stability issues with this specific 13900K. But we will still show you how to make it unstable. We
only tested a few 13900Ks, and I haven't tested any 14900Ks here. Yeah. So yeah, for us there's only like a limited amount of CPUs we can test, so our scale is very limited.
Yeah, that's also why we have a 13900K right now and not a 14900K, because from the 14th generation we only had the 14700K.
Yeah, and that one's stable as well. So
yeah, and that one is also, I think, less people have issues with a 14700K than seems to be the case for the Core i9 version.
The initial report was like 2 editors having stability issues in games with 13700K and 13900K, and later with 14 series, so 14900Ks.
So it is also
that's
possible.
That's what triggered it all, and I think it was in, well, as if I remember correctly, it was around February.
Yeah.
So that started it all, and then more people chimed in and said, okay, I also have stability issues. Then the 14 series launched, and more people seem to have issues.
So that you did a lot of testing around this topic, a lot of benchmarking, and trying to figure out what the issue is. Can you briefly explain in very simple language, I know that's always the hardest part, but in as simple language as possible, what is the issue that some people are experiencing, and how are we going to address that today? How should people deal with it?
Yeah, basically what the problem happened because there were no rules. So no rules means that...
That was the Eurovision contest song for Finland, I believe. It was called No Rules.
No Rules, okay, yeah, I haven't watched that. So, if everybody is free to determine their own BIOS defaults, then something can happen, and that happened. So that's simple words. Simple words meaning motherboard manufacturers try to squeeze the most performance out of each CPU. So the higher end you have to squeeze harder, because otherwise it will overheat, even with the 360 all-in-one water cooler. So you have to keep the power down to get it to boost as high as possible. In order to do that, you need to undervolt. And if you undervolt, there is a limit for each CPU, and not every CPU is created equally.
So this is basically the silicon lottery that we also have a lot with, for example, overclocking, but also undervolting. Not every CPU can reach the same settings, basically.
Yes.
And now that's also the case here, right?
And the higher the SKU, so the i9 14900KS is pushed the most. So expect that it will fail easier than the other ones.
So the higher end your CPU, the easier you can get stability issues.
And the less undervolt you can apply to and still have a stable system.
Yeah.
So the undervolting part is done to squeeze the most performance out for motherboards manufacturers to get good results in reviews. And
so this is also something that, for example, for AMD we know Curve Optimizer, and there you also see that if you undervolt it, so if you set a negative offset, it produces less heat, so it's able to boost higher, so you get more performance.
Yeah.
And that's also kind of what Intel is doing here out of the box.
No, Intel isn't doing this.
It's
the
more
motherboard manufacturers.
Motherboard manufacturers, they already go for a slight undervolt, so the CPU boosts higher.
Yeah, the difference between AMD and Intel is that in Intel, the default was the undervolt, and for AMD you have to apply it manually. So the default was not undervolted. So the rules for AMD are set clearly, and the rules for Intel were very free. So everybody can just make up their own defaults.
And then you also get the issue, for example, we as MSI, we have a certain set of CPUs in our headquarters that are used for testing. But that can also be the case that if we basically won the silicon lottery, we apply certain settings for the CPUs we have. And that's, of course, always a limited number. But some people may have had a slightly worse CPU. We sometimes call it potato CPU here. Maybe that's a little bit negative. But basically, you have different CPU qualities, even for the same CPU. And some are very good, and some are a little bit less good. And if the BIOS profile may work fine on some of the good CPUs, but if you apply the same settings to a CPU that is not as great in terms of silicon lottery, then you get the stability issues, right?
Yeah, that's correct. That's exactly what happened.
There are a lot of things going around on the internet with different power limits, etc. Can you maybe explain a little bit more about that, and how does it apply to this specific issue?
Well, in the beginning there was like a lot of rumors and not really clear answers from Intel, or at least not publicly out there. So then everybody was guessing some stuff, and then also weird profiles, like also the name baseline profile came up, and there were also data sheets that were misread, so they put the wrong AC load line and the DC load line settings.
Can you maybe briefly explain where the baseline comes from and what it actually is? Because there was a lot of misinterpretation about what does the baseline mean.
Apparently there's like a VRM spec which had the name baseline spec in it, and that was the bare minimum a motherboard needs to be able to supply. And that's where the 188 watts power limit came from. So that's the minimum that a motherboard can do on a sustained load. So
then you're usually talking about a more entry-level motherboard?
Yeah, for example, an H610 or something. That in that kind of range you should look at it. Yeah.
And even though motherboards in that segment can technically run a Core i9 as well.
Yeah, but with limited
you will
power
cripple
limits,
performance.
Yes. And with those boards, we don't apply the undervolting parts. It's not even possible, because the H and the B chipsets in the beginning were not allowed to run with a famous setting now, or at least now it's famous. The current excursion protection needs to be enabled. So.
And what does that mean, the current excursion protection?
That's a bit of a tricky one, because if you try to undervolt by playing with the AC and DC load lines, basically the voltage drops, but the CPU still, it's still cold, or relatively cold, so it wants to perform and wants to draw power. If the voltage drop and it needs more power, it will increase the current. And the current has a certain limit, and if it spikes, then the current excursion protection will kick in. And it works in a very weird way, because then the power draw is still quite high, but the performance isn't. I can demonstrate it later on. But then it's like something called phantom throttling, and then the performance drops to like 50% or so, depending on what settings you are using. And that's very similar to what we had when the V-in from the X299 was dropping below a certain level. There's a different platform with an integrated VRM in it, so a very different situation, but yeah, the phantom throttling meant the power draw is still quite high, but the performance isn't, so internally there's some throttling going on. And that's what the current excursion
So it's not easy to spot, but
No.
there is throttling, and you basically see it in your benchmark result.
Yeah, but if you're not running benchmark, so for example, if you just run Prime 95, you would never see it that the CPU is running very slowly.
Because the clocks are still high.
Yeah, and the clocks are showing high, at least in the software monitoring, and also the power draw seems to be also quite high. Yeah, that's the weird part about it. So that the current excursion protection used to be on for at least the B and the H chipsets, and for the Z you can disable it. So for all K CPUs, our BIOS default was disable CEP. Why?
Because also
because you
these
can
are
undervolt it.
Because there are higher end motherboards with a better VRM, they can run those higher settings.
Yeah, and it's okay for those motherboards to deliver the more power, current in this case. So the current is not a problem, and the motherboard will not be affected, or the VRM will not be affected by it. So just run lower voltage with higher current, and that means it will run slightly cooler than if you run with higher voltage.
Then, apart from the baseline profiles, maybe some people already saw some tables on the internet. There are two more profiles. So you have performance and you have extreme as well.
There is, the Intel default settings, that's at least what Intel calls them, and they were published on Tom's Hardware, and I think also Hardware Lux in Germany.
We have the table right there.
The CEP is an interesting one, because we made even a press release about that we could disable CEP, or current excursion protection, on B760 motherboards for 14 gen CPUs, which wasn't possible before. So basically at that time nobody really seemed to care that much about CEP, but in hindsight it meant that it could create the instability problems, and in tandem with the AC load line trick they're playing.
So what else do we see in this table? Because now the baseline profiles are all at NA, because basically that is not a profile that, especially if you're running an i9 CPU, should use.
That's not in the data sheet of the 13 or 14 gen CPU. So that's a VRM spec that was basically the
So it's not really a CPU profile, but rather a motherboard profile. What is the minimum
hardware spec? So
the minimum an LGA 1700 motherboard should basically be able to provide in terms of power.
Yeah, so they removed also these settings, and because that's not an Intel default settings that Intel wants you to use.
And then you see performance and extreme, and those are filled out. What is the difference between those two?
Yeah, performance and extreme is basically for the K CPUs, that's the top one. I believe it's hard to read from here, but the difference between those two, that's better.
There we go.
The difference between those two is that you'll have PL1 and PL2. And there's also a PL4, but
so that's the short duration and the long duration power limit?
The long duration is PL1, to be confusing, because first PL2 will be kicking in, and once the duration has passed, then PL1 will take over. So PL1 is always smaller than PL2 or equal. So PL1 will drop to 125 watts, and with a K CPU that will happen after 56 seconds, or at least that should be the default.
So for example, you run a 13900K, you start Prime 95, then the first 56 seconds you will see the 253 watt, and after those 56 seconds, it will drop to PL1, the long duration power limit. So then it will drop to a continuous power draw of 125 watts.
Exactly, yeah. That also happens in other programs that draw enough power. Yeah. So that could happen with, for example, 3D rendering or compression applications, or sometimes even games, but there aren't that many games that hit that kind of power, or continuous power, I should say.
Yeah, so usually in general the power draw is a lot lower, but it's also just, it is not like a full load like you have with Cinebench or Prime 95, that it's a continuous load on the CPU.
Yeah. So sometimes with games the load will drop, and then the counter will also reset, so you will still have the PL2 for another 56 seconds. But not only the power limits are important, also the ICC max. With most Z motherboards, they're always set to unlimited. Same goes for the PL1 and the PL2, at least in the default configurations before Intel announced that we have to follow this.
So basically, they can draw as much power as they want/need.
Yeah.
Because for the motherboard, it's no issue, and it may still throttle based on temperature, of course, because it also depends on the cooling you have on there.
Yeah, you can also play like a trick with the TJ Max offset, but I haven't seen defaults that did that. So you can raise the maximum temperature of your cores to 115, I believe, but I've never seen that to be the default for BIOSes, at least from MSI. I've never seen it, and also not from other manufacturers, so that shouldn't be a problem. But the ICC max and the power limits, those are a little bit tied together, because that's how much power you're putting into a CPU. And with the extreme profile, you have more, especially more ICC max current. I think that's more interesting for the KS CPUs than it is for the K. Most K CPUs will be okay with 307 amps. But then again, it's also depending if you're playing the undervolt game or not. So if you're playing the undervolt game, you need more current to compensate.
See, a couple of questions in between. Higlot is asking, will you do the same with an AM5 system? I know today we'll only use an Intel system, Core i9-3900K, but also what Ruud just explained, it doesn't really apply to AMD, right?
No, the AMD settings were always clear to every motherboard manufacturer. So basically, AMD has set the rules very strict and said, okay, this is the power limit, these are the currents, and these are for different CPUs. You have different set of rules, but those rules are clear. So there's little playroom for BIOS manufacturers or motherboard manufacturers to squeeze more power or more performance out of it. So there used to be, in AM4, we had, there was a trick, and it was also discovered by the guy who made HW Info, and he had like a power, there was a, what was the name? The power correctness factor or something. And there were some biases that played the trick, so they told the CPU basically it was running less power than it actually was. So yeah, that's basically also similar is going on with the Intel part, at least as far as I can tell, because I also don't get all the answers.
So basically, people running an AMD system there, this is not applicable.
Not
but
anymore,
also,
no.
in case you're running an Intel system, and even if you have one of those high-end Core i9s, for example, if you're not running into stability issues, then you can keep it as it is, right?
Yeah. I would definitely do that. Yeah. And if you're interested, you can still set like a power limit if you want your system a little bit cooler.
So you can still optimize it, try a little bit of undervolting if you want.
Yeah,
but
exactly,
at a certain point, of course, you will, if you start undervolting and if you go too far, you will automatically run into stability issues, basically.
Yeah. The further you undervolt, the sooner you will see stability issues. But if you don't undervolt, you will run probably into thermal limits. So
So the undervolting, if your CPU can do it, can give you better performance.
yeah, definitely. Yeah, with the same cooler, it will give you better performance. Yeah.
So it is worth it maybe
Yeah,
to
so-
tingle. If you know what you're doing, then I would say undervolting is usually worth it to.
Yeah, and
to tingle
I
it.
think that most BIOSes already do a pretty good job, and if they've squeezed it too far, then you just have to step it back a little bit. And
Yeah.
we will show you how to do that as well in a MSI BIOS. Yeah.
And also for the AMD users, because AMD has quite set rules, but those are also relatively safe, which
Yeah.
also means that generally you have quite a bit of headroom still what you can do in terms of undervolting. Because I personally, I've tried quite a few AM5 CPUs, and every single one of them I was able to use a negative offset. So basically use curve optimizer through PBO, and with a negative offset you're undervolting it, and all of them at least could do it to a certain extent, and it differs per CPU how far you can go. And in my experience, I don't know if you agree with it, but the lower end AMD CPUs, so for example a Ryzen 5 or Ryzen 7, tend to go with a bigger negative offset, so a bigger undervolt than what you're able to do with a Ryzen 9. But they all could do at least something, and in all situations you see the same story, that temperature and power draw lowers a bit, so the CPU is able to get a higher sustained boost speed, and you get more performance basically.
Yeah, or a lower temperature with the same cooler.
Yeah.
With AMD, you can also set like a temperature target, and you could also set like the power limit. It's called PPT with AMD, and instead of the power limit or PL 1 and 2 for Intel.
Yeah, so basically a different name for basically the same thing.
Yeah, exactly. Yeah.
I see another question from Thomas on YouTube is asking, will these new BIOS settings affect 12th gen CPUs?
Oh, that's a good one. Yeah.
So will it?
I haven't tried it. Yeah. The discussion was very focused on 13 and 14 i9s, K and KS.
So basically, at this point, it doesn't look like there specifically is an issue with 12th gen.
I think because Intel is forcing us, or all manufacturers, to do the Intel default thing as a default setting for all CPUs, so not only for these listed here, so these 4 listed, but also the i5, the i3s, the Pentiums, the 12th gen, everything. So if you're doing Intel default settings, then it should be following the Intel spec. With the non-case, that was already the case with any B or H chipset. So the B or H chipset have 2 choices: either go with Intel default, more or less, or with a restricted power limit, because then it will protect its own VRM. So sometimes the power circuit on an H610 is not equipped to run 253 watts through an i9K. Yeah. So yeah, that's something that needs to take into account.
Schnips86 also saying on Twitch that 12900K is basically a 13700K.
Yeah.
Yes and no. In terms of core count, it is, but 13700K is clocked a little bit higher, and usually that also means to a little bit more power draw, but also it is slightly easier to make a 13700K unstable than a 12900K in that perspective. I believe there's also a slight cache difference, isn't there, between 12 and 13?
I don't think so.
No? Identical?
But the 13700K was maybe like 15% faster and 15% more power hungry. So
yeah.
So it's basically the same.
But more than 15%
efficiency.
more sensitive to instability, maybe.
I don't know, but yeah, it was, yeah. It did a little bit better on the single-threaded stuff.
Yeah, because of that higher clock speed.
Yeah.
Yeah. Uncle Elias says, it seems like 13th and 14th gen i9s, from everything I've read and heard, I think no one is seeing the same type of issues in i7 or lower or older generation. Not entirely. I believe there are some i7s that are also affected, right? So for example, 13700K, 14700K.
At least there was a discussion between two editors, and one editor was having an i7 13700K, but
it seems to be less common, at least, than with Core i9s.
If you build a 13900K or 14900K system and it's unstable, it doesn't have to mean that it's this issue. You could also run into other issues. Hey, maybe your power supply is not really functioning well. Maybe your cooler wasn't attached correctly. Maybe the memory isn't compatible, or you clocked it too high. There's certain things that still can go wrong, but that can go wrong on any system, also on an AMD, also on an i3 or a Pentium, whatever. You know, so it doesn't need to be a high-end system to go wrong. But this specific part is to blame on CPU quality variations and motherboard vendors pushing the undervolt a little bit too far.
Zizi is asking, will these MSI parts be covered under warranty if you need to contact MSI for RMA? What do you mean exactly with your question? Because basically this is a settings thing, so it's a combination of motherboard settings with CPU quality, and it could be that the out-of-the-box settings of the motherboard that are targeted at basically optimizing CPU performance are not able to run on a specific CPU if the quality is too low. But by adjusting your settings, later on we will go a little bit deeper into that. How can you do that? What should you change? You can of course still run it. It's not that the CPU is defect or the motherboard is defect. It's basically a mismatch between CPU quality and default settings on the motherboard.
Yeah. Also, a lot of people are discussing stuff like CPU degradation or silicon degradation, but I don't think that's the case here, because at least MSI is not pushing high voltages into the CPU, so it's rather too low in a high load situation than it is high voltage on a high load situation. Yes, there are still options in our BIOS. For example, if you have a 14900K or KS, there is an option in the BIOS called beyond 6 gigahertz. But that is basically taking advantage of the thermal velocity boost of that CPU and running that all the time if you're doing light loads. Light loads meaning like 1, 2, 3 or 4 threads loaded, not the full CPU loaded. And yes, then the voltages can get a lot higher, but that's with a relatively light load. I mean, it's not that you're running all cores and pushing like 400 watts or whatever. So in that situation, I think the voltages will not deteriorate the CPU silicon that much. But that's a setting that's never been on for default, so that's people deliberately doing overclocking.
Yeah. Mike Yell is asking on Twitch chat, I see that MSI is setting a way lower power limit and amps than Intel recommendations. That really hurts performance, and is MSI aware of it?
That could happen on entry-level boards, but normally for the Z boards we have no limit. So no limits is definitely higher than Intel recommendations.
Yeah. So it's basically make a wise combination of a certain motherboard and a CPU. Like if you're going for an entry-level H610 motherboard, which does support LGA 1700, so technically, if you have the right BIOS version, you can run a 14900K on it. But don't expect the 14900K to perform the same as it would on a Z series motherboard. H610, of course, is a way more affordable motherboard. It has a more basic VRM. It may not have additional cooling for the VRM, and that's also why those stricter power limits are in place for an H610 board than the unlimited limits basically we have on a Z series board. So it all depends on the combination that you make, and yes, it does hurt performance if you run a 14900KS on an H610 motherboard, because the H610 motherboard is not made to run such a high-end CPU. So even though, yes, technically it does support it through the BIOS, it will hurt performance. So if you choose a very high-end CPU, make sure to go with a motherboard that is able to supply sufficient power in order to run it at full performance.
That's not Intel only. Also, if you have an AMD board, for example, you have a A620 motherboard and you put like a Ryzen 9 on it, then it will also be restricted to power because the motherboard cannot supply enough power to fulfill the power limits of the Ryzen 9. So that's a similar situation that has nothing to do with what MSI chooses in the BIOS. Also not for Intel. So if we have a high-end motherboard, then rest assured the power limits before today were always set to unlimited. And also the ICC max. Let's go over the rest of the list, right?
Sorry?
There's more stuff on it than just the power limits.
Yeah.
Or did you want to do something else?
I wanted to quickly talk about this.
Yeah, that's basically the rest of the list as well. Yeah.
Because this is a comparison between the Intel default settings on the right, and on the left you basically see the unlimited settings. So this is what you
settings. And don't get me wrong, the new BIOSes with the Intel default settings as the BIOS defaults still have the water cooler settings in them. So the old defaults are still there. You can still choose them.
But you have to select it manually if you want this.
Yeah, that's exactly true. Yeah. So if we go to the first one is long duration power limit, that's basically PL1. And on the left it's set to 4095 or something. It's hard to read from this distance.
4096 watts.
96
so basically
watts,
that's
basically
that's just unlimited because you will never get not even close to this.
Yeah. So for the Intel default it's 125 watts. Since the water cooler is set to unlimited, the long duration maintained seconds is useless because the PL1 and PL2 are basically the same, so the seconds don't really matter. For the Intel default one, it's 56 seconds, so this was done with a K CPU, and then 56 seconds is the default.
And there you do see a difference between the K and the KS, right?
Yeah.
Because if we go back to this one, there you see that for the KS, which is on the very bottom, you see that PL1 and PL2 are the same. So essentially...
So basically Intel has two profiles you can choose from, and MSI has chosen the performance profile, not the extreme one. So if you put a KS in it, then 253 watts is basically PL1 and PL2, but ICC max is still at 307.
Yeah.
So some motherboards choose the extreme one or something in between. That's also possible.
But even if the performance one is here, for example, the Intel default one, that doesn't mean that you cannot do higher. It doesn't mean that you will always be restricted on performance or amps or power limits, because you still can choose a different setting where it goes way beyond even the extreme setting that you see here.
Yeah. You can set it to unlimited, and that's basically what the water cooler part is doing.
Yeah. But of course, this does depend on your motherboard, because not all motherboards can support this, and the power limits you see here will not be applicable to an H610 motherboard, for example.
Also, if you drop in a non-K CPU, the power limits will be a lot different. For example, the duration, the long duration maintained seconds will be 28 seconds instead of 56 seconds. That's something that's also been default with Intel. We stick to that. Well, basically the power limits and the ICC max, and that is called CPU current limit in our BIOS. Those were usually set by the Intel boxed cooler settings we used to have. So when you have an older BIOS, or for example like a Z690 BIOS, those are not updated yet, or at least not all of them, then you will still be able to choose the Intel box cooler, but that's only setting the power limits and the current limit. So it's not setting the next part, and that's the AC load line and DC load line, which in our BIOS is called CPU light load control.
I see a comment on a YouTube chat. It was a couple of minutes ago, but Ted Branston said, no point in getting a K chip if you have to run it stock.
Oh, that's not true, no.
And why don't you agree with that?
No, the K CPUs still have a much higher power limit than the non-K CPU. So since, for example, to take the i9 13900K, which has a power limit PL2, so the short power limit of, I'm not sure exactly, but it's probably like 240 watts or something. So the first 28 seconds you will get nice performance, but after 28 seconds it will drop to 65 watts. That's a huge chunk out of the power budget, and that means so.
And also a huge chunk out of your performance.
You will have an i5.
Yeah.
And so an i5K will be faster than your i9 non-K. So that's a bit of a thing. So Intel's not only forcing motherboard manufacturers to do this for K CPUs, but also for non-K CPUs. So that will be even more hurtful for the non-Ks than for the Ks, because the Ks still can do 125 watt. But it does level the performance a little bit. So if you have a 13900K or a 14900KS or the other two in between, they will perform very close to each other. Somebody says that sounds like a mess. Well, yeah.
Yeah, that's why we tried to clear things up a bit today, so people know what to expect, you know how it works.
Yeah, exactly. We try to just clarify what's going on and what Intel is forcing motherboard manufacturers to do with the BIOS defaults. So yeah, for MSI, we have already released them for C790 motherboards, and later on the Z690 and all the other boards will also receive that update. As far as I know, we need to have them ready before 31st of May, and then it should be okay.
So that's quite soon already?
Yeah. That's quite soon, yeah, exactly.
1.5 weeks?
Yeah.
Estegard was saying on Twitch chat, as someone building on a 12th gen, I'm feeling lucky I went old gen. Well, in terms of, I think earlier I saw you were building with a 12600K. Well, first of all, for the money you pay currently for 12600K, it's still very good value, I think, in terms of the performance it provides. But it's not necessarily like the newer generations are all of a sudden awful, because you may need to change a bit with the settings. You just have to be aware how it works, where problems can arise, and how to solve them. And I think basically, of course, unless you really have a broken CPU, also if you didn't win the silicon lottery, you can still get a very well-performing system, but you may need slightly higher voltages in order to run it stably than what someone else would who did win the silicon lottery for the same CPU. Talking about stability and voltages, Penorian Gray is asking, why is light load 16? Isn't that more voltage than mode 9? Is there a reason to have it higher? Thought you want to have it as low as possible.
That's true. That's also what we used in our, I think it was an undervolt stream some time ago. The light load mode, the lower you go, the lower the AC load line setting will be. But the DC load line setting will stay the same. So normally it's set to 1.1 milliohm, at least on the Z790 and the Z690. And so it seems to have, the trick seems to be, I'm not 100% sure about it, but the lower you go with AC load line in comparison to the DC load line, so the DC load line, if you keep it high and drop the AC load line, then the CPU thinks the voltage is okay, so you can get away with it until you enable the CEP, so the current excursion protection. But it seems to be a trick, because if you look at the wall meter or any power, like a current clamp or whatever, it's still drawing quite a lot of power. So it's playing a similar trick as we saw with the AMD one with the AM4. So it's trying to pull something on the CPU that the CPU thinks it's drawing less power than it actually is. So if you look at the blue slide from Intel, if you can pull that one up, yeah.
Yeah.
AC load line, and says varies, see note. So basically the load line, any VRM on any motherboard will have a load line, will have some resistance, some impedance. And you actually need to measure that part with a VRTT tool apparently. At least that's what the Intel datasheet says. And that value should be in our BIOS. But at the moment it's just set to a very safe 1.1 milliohm, which is the maximum Intel allows. So the 1.1 milliohm means it's setting the voltage quite high, but that's also the reason for this Intel default settings, to make it more stable. So give it more voltage, it will run more stable. If you lower the voltage, it will run less stable. That's basically what this is about.
And this is always the trade-off, because if you set the voltage higher, there is a bigger chance that it will be stable, of course. But if you set it lower, that may, if your CPU can do it, give you better performance, lower power consumption, lower temperatures. But so you don't want to go too high without a good reason for it.
But the trick seems to be that the AC load line needs to be lower, much lower than the DC load line. While this document says that AC or DC load line must match AC load line. And if you need to match it, so if you lower them both or raise them both, they don't seem to do that much. It still does a little bit, but the trick with the underfolding was that the AC load line was much lower than the DC load line. So if you keep them the same, then the performance difference is not that much, and the voltage and power difference is also not that much. So then it's just matching the AC load line with the actual impedance of the motherboard.
Michael is saying in Twitch chat, so Intel recommendations now mean something, but older gens, so for example 9th or 10th generation, no one really followed it.
True, yeah. It was also unlimited, yeah.
Yeah.
But those limits were still close to the 253 watts or even lower. So with new CPUs, for example, the 13900K.
They can go way beyond.
Yeah, if you just run them in water-cooled, unlimited settings, then with Cinebench it will do 320 watts in the peak, and with Prime 95 it will do more. So 350 is not a problem. That's way beyond the 253 watts that Intel specified for it.
Yeah.
But if you take a 10900K, for example, if you run that maximum, it will maybe do 240 on Cinebench, and it will do 260 on Prime 95. That's still quite close to the 253 watts that Intel specified for it.
But it's not way beyond like you see with certain current high-end CPUs.
I don't have a 14900K, but that will probably go over 400 watts with the default settings, yeah.
And the KS?
KS, sorry, yes. Yeah. I meant the KS, yeah. The KS was the one launched.
But also the 4900K, I think it's also 320 approximately?
Which one?
4900K.
Oh, 320, no problem. This one does 320 already. Yeah. So I can do 350, but the cooler will probably just,
at a certain point, you just run into the limits of what you can cool on such a small area as well.
With an all-in-one water cooler, yes. Then you need like a custom water loop or whatever.
But even with a custom loop, you will also, at a certain point, you will always run into the limit of what you can cool on the size of the
such
CPU.
A small surface,
Yeah, it's not like a high-end desktop platform CPU where you have a bigger surface area.
No.
So you can add 5 radiators in a custom loop, but it's still such a small area that where you need to transmit all that heat through.
Yeah, maybe phase changer or delit it or LN2. Yeah, but that's only like brief operation. It's not 24/7. The Intel default settings is for people who just want to have a stable system and have great performance. I mean, still with Intel default settings, you will have great performance out of it.
So basically, it's a set and forget setting.
Yeah, it's a safe setting, and it will still have very good performance. But if you want to have the most out of it, you can still tweak it.
Forbes is asking in YouTube chat, guys, what power limits would you recommend for an i7 14700KF?
That one is also quite close to the 253 watts, I think. Yeah, it's a little bit higher, but not that much.
So you wouldn't lose too much with the 253 watt
No.
power limit?
Personally, I think we set the performance profile for the K, and I haven't tested the KS one, or KF. K or KF is the same. The F just means it doesn't have integrated graphics. Yeah. So the K and the KF, they will be limited to 125 watts after the 56 seconds. I would disable that part immediately. So if I were you guys, then I would just build the system, set it to water cooler. If it runs stable, leave it be. Just water cooler, XMP, that's it. Nothing you need to do more. If it's unstable, go to the Intel default settings and then set the PL1 to 253 as well. So basically you'll get like the extreme profile more or less. You can even add the,
or you basically start
Max.
running it as like a 14700KS. It doesn't exist, but that's kind of what you do with the settings then.
Yeah, but even if you give it the 400 amps on the ICC Max, it doesn't really matter that much. It will probably not run into that limit anyway, because the 400 amps was basically really the KS territory, not the K. So yeah, depending on the settings still, yeah. But the water cooler, I think the majority of people will not run into issues with the water cooler settings, but some do. And if that's the default, yeah, I can imagine that people are not that happy.
Shall we maybe dive into the BIOS a bit?
Yeah, I've set it up so now it's water cooled. So basically, there are some tools to run that can show you what the current settings are for your system. I'm using HWinfo64 because, well, I always use that. That's one reason. The other reason is it's one of the few tools, or at least the only tool I could find that could display which AC and DC load line currently is applied to your CPU. So basically, we're running water cooler settings now to show you the old situation. So first I will show you what kind of system I have. The system is a Z790 Ace Max, so a new motherboard with a 13900K.
So very high-end motherboard as well, so we can set this to unlimited and the VRM will be fine.
Yeah, and I have a 4090 Supreme X in it with a M480 SSD and 2 sticks of Kingston memory, at the moment running at 6400 megahertz. Because I don't want to push the memory too far, because then I don't know if the memory is failing or the CPU settings that I'm applying are the ones that are causing the issues. So I just set it to the safe 6400.
Just so you know, if there is any stability, it's on the CPU side and not on the memory side.
Yeah, exactly. Yeah. So the power limit, the long duration, is set to unlimited. That's the 4096 watts we see in our BIOS. And the short duration is the PL2, and that's also set to unlimited. You can say that the seconds are, or the time window, or tau, is 56 seconds, but if both are unlimited, there is no time to expire, so both are the same. Then if you scroll down a little bit, there's a lot of stuff here that is not directly interesting for us at the moment, and the next one will be, I think I already passed it, right? Yeah, I already passed it. Oh, here's the oh, here, the ICC Max. Yeah, that was the one I was looking for. Also set to unlimited. So sometimes I see it as 511.75 amps, but that's basically also unlimited. So so the unlimited part for the ICC Max, and here you can see the the CPU core, AC and DC load line. So it's 0.4 milliohms for the AC load line and 1.1 milliohms for the DC load line. There's also a part for the graphics, but graphics is not really a thing we're overclocking or undervolting, so at least we're not using it now at the moment, so we're using a GPU instead. But this is at the moment the only program I could find that could read this information. And it seems to be accurate, so if I set the same settings in the BIOS, it will just show up here as well. So that's good to know if you want to check your own BIOS settings. Then, 0.4 is not equal to 1.1, so we're definitely breaking that rule here as well. The other parts of the blue diagram regarding the C states and stuff, I've never seen the C states being disabled by MSI BIOSes. The thermal velocity boost were also disabled or enforced in the water-cooled BIOS. So it's applying thermal velocity boost also when it's with a hotter temperature. So that's also not Intel spec. So you try to boost as much performance as it can with the water cooler setting. So I'll close this now and just run the sensor part of HW info. Then we can see what's going on and how much power it's drawing. And let's run Cinebench, because then at least all cores are loaded and we know for sure that we will get some big power. Also have a power meter here, and that one is ramping up to 484 watts at the moment. And
but that is for the total system.
For the total system, and you can see the CPU power is reaching 320 watts. So this is not even a power virus, this is basically a workload that you could actually do. You get about 40,000 points in Cinebench 23. Fluctuates a little bit between 39.8 and 40.23, something like that. But that's basically the ballpark you can expect. Also depends on your cooler and stuff, because if you look at the temperatures, it goes to 98 and 99.
And this is with
very
a big
quickly.
Cooler.
Yeah.
Because quick check, 360 millimeter all-in-one liquid cooler.
Yeah. So I also ran the single core benchmark and also compared it with the other settings, also with the Intel default settings. That's not affected because it will never run into the limits that are set by the Intel default settings. So you can test it, but it takes a long time, and if you need to run a lot of benchmarks, then we're just waiting for the benchmark to finish. I think it takes about 6 or 7 minutes per run. So I don't want to do that in this live stream. That will take too long. So this is basically what you can expect. If you run it for 10 minutes, it will just keep on doing 320 watts or as much as the water cooler can cool. So there's no limit, there's no time to expire and then drops to a lower power. It will just run as much as your cooler can handle and the rest can handle. So if we go to the BIOS and set the Intel default settings, then we can see what's going on. Shall we go to the BIOS?
Yes.
Yes. I need to unplug the display port.
It has a special trick for this.
Yeah, this is something we always have to do.
Yeah.
We go to the BIOS and then I unplug the display port. So
otherwise he would get the BIOS screen on his monitor.
will get the BIOS, so I will read the BIOS there and not on my monitor.
Yeah. So you guys can also see what Ruud is doing.
Yeah, exactly. Yeah.
At1K is asking in YouTube chat, how many millivolts can I undervolt at 10700K with which setting in the BIOS?
You can do also the offset voltage in any Z motherboard BIOS. That's also something you can use.
Yeah, but it's impossible for us to tell how many millivolts you can undervolt.
Yeah.
Because it depends on the quality of your CPU.
Yeah.
One 10700K can do a lower voltage than another 10700K.
Yeah.
So this is really the trial and error zone that you're entering. So try it out, see if it works, and otherwise make adjustments.
Yeah. There's only one advice, and that's go slow and with small steps. That's the only thing I would advise. But here's the offset mode, or adaptive plus offset mode. Then you can say I want to have a core voltage that's auto, but the offset mode I want to have negative, and I want to go for 10 millivolts, something like that. That's something you can do. And if that's stable, I'll do 20 millivolts and so on and so on.
At a certain point, it will run.
Just an example, but that's not the topic for today.
No. And as soon as it becomes unstable, higher it again.
Yeah, exactly. And test everything, because if you're playing with offsets, then also the low power situation, so if it's almost idle or just very light load, can still crash, because if the voltage is too low.
For me, that was actually more uncommon. I run an AMD system myself, and of course I've also been, because I always use mini ITX, so for me undervolting is essential, and I do that through curve optimizer with AMD. When I went too far with my negative offset, so with my undervolt, it would become unstable in idle situations, not under load. So I could run Cinebench, for example, just fine, 100% CPU load, because it will automatically higher my CPU voltage. But at the lower load, sometimes just sitting on the Windows desktop, it would just crash out of the blue. So it is definitely...
it's tricky.
Yeah, it is tricky, and it's also something you will not be able to have your definite answer within 10 minutes of testing. You would need to test this over a longer period of time, and it can still be stable for hours, and then all of a sudden it crashes. And then you higher it a bit again, basically until you find that point where it never crashes anymore. If you want to be safer in terms of stability, then just don't use a very aggressive negative offset. Then you can be a little bit more conservative with it. Of course, the power draw will be slightly higher and your CPU may boost a little bit lower, but at least it won't take you as much time to find that exact sweet spot, because it takes time. You will be annoyed sometimes if it apparently doesn't work after 7 hours of running fine. But yeah, indeed, but very much in idle, I would say, at least with my AMD system, is more sensitive to stability issues than under a higher load like Cinebench or even gaming.
So here we find the CPU cooler tuning. Also, if you change the CPU to a different model, or if the board is new, it will pop up with the cooler selection. But it doesn't always do that. So if I clear CMOS, it doesn't show it. So we're still trying to work out how that should work. I think it should always show. Anyway, we can also see in the advanced CPU configuration what the power limits are, or, well, actually there are no limits. And these are the settings that was also shown in the presentation. And also the thermal velocity part, that is disabled, and the clipping is disabled. And the optimizations are still enabled. And
Siggy Janssen was asking, what's the LLC on auto? So the light load control?
This is the water cooling settings. So normal is mode 9 for the K CPU, which is 0.4 milliohms and the 1.1 milliohm for the DC. Well, the DC actually always 1.1, except for light load mode 1, I would say. Then it goes to 0.1 milliohm. Yeah, 0.1. Anyway, it's hard to see, but here it says IA CEP support. So this is the current excursion protection support, and that's disabled. That's an important one, because that doesn't play well with the mode 9 here. So if I change this to advanced, then you can see the actual AC and DC load line, but it's in a different format. So 40 means 0.4 milliohms. And the first block we did is how to get more stability. Is change the CPU light load control to Intel default. If you do that, then it will go to 1.1 milliohms for both AC and DC load
Let me
line.
quickly show you the blocks as well. So if you're on our website, if you go to what's new and blog articles, there you can find different blog articles. And we also made some blog articles about this. One is from the 25th of April.
Yeah.
And the other one is from the 9th of May. So this is the one you were referring to, right?
Yeah, this one only talked about the light load control and set it to Intel default. That will help a lot because it will raise the voltage, so it will basically turn off the undervolting part.
Yeah.
But at that time it didn't set the power limits yet, or enabled CEP, or enabled thermal velocity boost as it's supposed to do.
Yeah.
So, but it's still a good advice, and if people want to play with it, if you go with the light load mode 9 and that's stable, you can go lower. If you go lower, it means you can undervolt more and squeeze more power, performance out of your system, or your cooling system and your CPU. So you will run into thermal throttling later, so you can push it further. That's basically how the CPU light load trick works. And this is just a name MSI invented in their BIOS, but with other BIOS manufacturers it will probably just be called AC and DC load line, like the advanced mode we use. So if you do advanced, then you can just punch in the numbers directly. So if you want to do 40/40 or 70/70 or 110/110, 110/110 is basically the same as the Intel default, or if I would run the F6, that's usually the default settings for load optimized defaults, is the BIOS default settings. If I run those, then it should, well, it doesn't change immediately, but it does set this one to Intel default settings. So basically it will apply the power limits, it will set the AC-DC load line to 1.1 milliohms, or mode 16, and it will enable CEP, will enable TVB. TVB is a thermal velocity boost. So if I do this, then it's in the right settings that Intel recommends. I always click XMP because otherwise it will run at 4800. That's kind of low, but 6400 is pretty okay for me. So if we do F10, save and exit, then it will just show you that we've loaded the Intel default settings, and XMP was already at XMP3, so that part hasn't changed.
That's still the same. No.
So let's benchmark this one and see what happens, right?
In the meanwhile, while you are booting again, let's do our first giveaway for today. So if you haven't participated yet, please go to msi.com/2/insider, or if you're watching on Twitch or YouTube, you can also follow the direct link that our bot puts in the chat once every 5 minutes. We're giving away several Steam wallet codes as soon as you're already signed up. Even if you don't win the first time, no need to do anything more. It will automatically be included in the next drawings as well. And our first winner for today, Ruud, can you read this?
SWAT Cats.
SWAT Cats, congratulations! You won our
Cats.
first Steam wallet code, so please keep an eye out on your mailbox. Then we'll email the code to you in the coming days with some instructions on how to redeem it. Congratulations. And make sure to participate if you haven't done so yet. And I think your system should have been booted by now.
Yeah, I think so, but I was watching at my monitor, but I unplugged the display port. So
There you go.
I thought, oh, why isn't it not run yet? Anyway, so if we go to the HW info again, we should be able to see that the settings were applied as they should be, at least the power limits and the current limit and the AC and DC load line. So here we have the long duration power. It's 125 watts. That's the performance profile that Intel recommends. with 56 seconds. Now the 56 seconds do have a meaning. And the CPU power limit, the short duration is set to 253 watts. And the current limit should be here somewhere. And that's set to 307 amps. If we scroll down further, we can find that the AC and DC load line is set to 1.1 and 1.1. So both are the same, which is what Intel recommends. So
a lot of these settings are very familiar when looking at this.
Yeah, so that's all good. So let's see what how it affects the performance. Before we had Cinebench 23 about 40.2 thousand points, 40.2K.
On the unlimited setting? Yeah.
Yeah, unlimited setting, and let's see what we get now.
With the
So
Intel
the wall meter says about 397, 97, 98 watts, and the package power is almost clipped to the 253 power limit. And luckily, Cinebench 23 is not a very long benchmark, so it will not drop to 125. But if I start it again, so now it's 35.5.
But that's also because this CPU is fast enough to finish it before the long duration power limit kicks in, basically.
So the 35 is still quite a drop, and it fluctuates a little bit. So here we see the drop in 125 now.
Yeah.
So that will affect the performance more.
So if you just do a single run, then you'll be fine. But if you
now it's
run
32
multiple times.
Now it should only have a very short one, and then you will see what will happen if you run it 3 times. So for longer workloads, you will be penalized with more performance drop. So the first one will be the best, the second will be okay, and the third will be around 29. So you go from 40 to 29. That's quite a drop. In my earlier testing, that was 26 to 27% you will drop. But the power drop is also immense, so it's
already with the
efficiency-wise, it's not that bad, but it's
Because even the first run, when it was still running at the short duration power limit, it was at, I think, it should be 253 watts now, whereas at unlimited it was running at 320.
Yeah.
So that's already almost 70 watts drop.
Yeah.
So that's also why you see a bit of a difference in the performance already in the first run, but especially after that long duration power limit kicks in, the difference becomes even bigger.
Yeah, and this is a 3D render workload, so the CPU will be fully loaded.
Yeah.
But I can also show you that it will happen during gaming as well. Well, not every game, because most games don't load the CPU that much, and you still need quite a lot of FPS to make the CPU work that much.
Because otherwise it will be below the power limits anyway, so it doesn't make a difference.
If your CPU is drawing only 110 watts in the game, then
it doesn't matter if you have a 125 watt power limit.
Exactly. Yeah. But of course we found a game that does show this behavior. So we're using the Riva Tuner overlay again. Should I put it to the left or to the right? Well,
doesn't really matter.
Maybe I should make it smaller. No, bigger. Is that better? Then at least you can.
Is it still readable for you guys?
I hope so. Otherwise, my head or my monitor will block the power limit or the power reading of the CPU. Yeah. So if we, I'm running a 4090 graphics card with full HD and ultra settings, no ray tracing, no upscaling.
Yeah, people are still able to see what it says.
Yeah,
good.
So So the power should be there.
Yeah.
Yeah.
Because the one on top is the graphics card.
So this one is doing 156, 58 watts. And that's quite a lot for a game, even for
it's beyond
this
that
CPU. Yeah.
It's beyond that 125
Now you
watts.
see it drop. Now is the power limit is kicking in. So the 125 will drop.
So it went from the short duration power limit to the long duration power limit.
Yeah, exactly. So the first benchmark run will be still the fastest, because you will have like half of the benchmark will still be unlimited, and then the second half will be limited.
Well,
But if you
technically
run
you're not
more-
unlimited, but it doesn't reach that limit, because technically 253 is now the limit, but it doesn't get close to that anyway.
No,
here.
no. So yeah, it's not
even in
hampered
a-
by the power
yeah.
limit.
Yeah, indeed.
That's a better word. Yeah.
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 So even with a demanding title, it won't draw 253 watts.
Yeah. The performance is a little bit. Oh no, the performance is lower, of course, because of the power limit. Yeah. If I run it again, then you will see that it will stay at 125, because it never recovers. It never drops below 125, because even the menu in Cyberpunk is very taxing on the CPU. So. Yeah.
Because the menu also runs at a very high FPS. Point.
Yeah, it's very strange. Some games they draw so much power in the menu alone already. That's it's not very optimized, I would say.
So guys, never leave your game running in the background, even if it's in the menu, because
Yeah.
it may still draw a lot of power from your PC.
Another one is like Shadow of the Tomb Raider. Then if you just run the menu, then I think it runs 300 FPS in the menu, but also draws a lot of power, and CPU and GPU.
Yeah, but usually, especially when you have a very high frame rate, that's where you see the CPU being loaded, and the CPU is starting to draw more power.
Yeah.
The
Of
fall
course,
is-
I chose very light settings for a 4090, so
Yeah.
we're searching for the CPU bottleneck. It's not a resolution and setting you would play on a 4090, of course, because
But
it's
then
not
you will move the
necessary
load to the
drop.
GPU rather than the CPU.
Yeah.
The fall is asking, does that program display temps also? Yeah, you can actually
Yeah,
see them as well for
Yeah.
both the graphics card and
Yeah.
the CPU.
So basically, if you're running longer on these settings, then the performance will be around 187 for this setup. And that's because of the CPU power limit. So we can go back to the water cooler setting and see what the performance impact is. Or we can just remove the 125 watt limit and see if it brings back the performance to normal situation. I think the last one is just as good, because you can still stick to Intel defaults and not breaching any Intel recommendations.
And for gaming, it won't make a difference because it will not go to that 253 watts anyway.
No, it will never reach 253, at least not these CPUs.
So basically, if that's what you do, then you kind of turn it into a KS queue almost, because that's what you're doing with the power limits. At least from a power limit perspective, because you make PL1 and PL2 the same.
Yeah. But that extreme profile is still allowed also on a K.
Yeah.
But yeah, I'm not sure, you have the slide, but if you also enable the 400 amp current limit for the extreme one for K.
I will pull it up.
Yeah, also, yeah.
Yeah.
Yeah. Let's do just 400 amps and 253 watts. We're still in Intel's recommended
Within Intel,
settings.
yeah.
Yeah, there we go.
Okay, back into the BIOS.
So basically where you change that is the same as we saw the power limits before, and now we can also see that they are applied correctly as intended. So 125 watts for the short PL1 and 56 seconds 253 watts for the short duration, and the current limit at 307. So if we only change this one and change this one to 400, we basically get extreme profile. So save and exit, and here we go. See if it brings back a little bit of the performance, or all of it.
Yeah, so now it basically manually moved it from the performance profile here to the extreme profile you see on the right.
Yeah. And I think it doesn't really matter for stability, because the voltages don't change. The AC and DC load lines still are set the same, and the only thing you can do is draw more power with a KS. So the Ks, yeah, I think that the current limit is not reached. The current limit can be reached, but then you also need to undervolt, and then you're actually breaking Intel's recommended settings again. You're still allowed to do so, but it's it's
but then it technically becomes overclocking, as they see it.
Yeah. Then it's overclocking, yeah, because it breaks the Intel default settings. So let's double check if everything is set correctly, and some settings are still the same. So the power limits are both 253 as we set, and the current limit should be 400 now, and it's set to 400, and AC/DC still at 1.1 milliohms, so that's exactly what we try to do. So now we should also see that performance should stick close to the 35-36 K in Cinebench, no matter how many times I run it.
So
it will not reach the 40, because that was a result of the
unlimited setting. So
the undervolt more,
yeah, but also it could draw 320 watts, and now it's still being limited to 253 watts.
Yeah.
But now, so still the first run will be lower than, of course, when you have everything unlimited, but at least now it will sustain the performance that it has in the first run, whereas with the previous settings, after you've reached the 56 seconds, it will drop in performance because of the long duration power limit being lower.
The first run was 35.5 K. Second should be close to that, so it should be
and second was previously where we saw the long duration power limit kick in, but now you do see the flat line at
the third one was 29 on the limited one, and I'm running it more closer together, so the heat will be more in it and the power draw, but you at least have an idea that the power will not drop.
So while this is running, you also made a nice graph out of this from your testing results. And let me see if I can get my pointer. There we go. So this is with the unlimited setting. You get over the 40K, and also your performance remains stable around that 40K. This is the default setting that we ran before. So the first score is the first round is high because you're still on the short duration power limit being 253 watts, and during the second run it drops to the long duration power limit being 125 watts. So then you see the score drop to slightly under 30K, and now basically you get the performance here from the default settings at 253 watts, but instead of dropping to the long duration power limit, it sustains that 253 watts. So basically, if you keep it like this, the score would flatline approximately there around that 35K score.
Yeah, exactly. Yeah.
Okay, back to your capture.
And this is run with the HW Info program also running. So the scores can be a little bit higher. Also, if you tune the memory, it can be slightly higher. But this is roughly what you will get. Also, if we go to the game, the Cyberpunk, the first run, the second or the third, this should all be the same. There should be no drop in power for the CPU, and the performance should be equal.
And this is of course specifically for Cyberpunk, because in other games the other setting may perform just as well because you don't reach that 125 watts.
Yeah.
So this is a very situational thing depending on the game you're playing.
Yeah, I briefly tried it with the Shadow of the Tomb Raider and Formula 1 22, but the CPU load was not that high, so it wasn't a good way to demonstrate this. So we went with this one because this showed the best result.
Yeah.
Or the clearest, clearest difference. And we again must say that the settings are quite low for a 4090. So yeah.
Again, to put that load on the
to
CPU.
put the extra bottleneck on the CPU, and you will see some differences. Yeah. The weird part is that it now shows that it's running at 230 something watts. Before it was 150 something. So there's also something weird going on with the Riva Tuno one.
Actually, it's now pretty close to that 253
Yeah,
watts.
there's something weird going on.
But
Maybe
now
I
instead of that
should've-
drop that we saw
Yeah.
previously, it now stays at the higher power drop.
Yeah, but the max with the other setting was about 160, let's say, between 150 and 161.
Mm-hmm.
And now it already started at 2 something, you know? So the power reading in Riva Tuner is not consistent. But we can fix that by checking the power from the HW info sensors page.
Hypermodel is asking, what's the giveaway? We're giving away several Steam wallet codes today. So to participate, you can go to msi.com/2/insider, or because you're watching on Twitch, once every 5
But
minutes.
the performance is where it needs to be.
You'll see
So
it in chat.
now it's at 208 frames per second.
Mm-hmm.
Before it was at 187. So that's something you can lose, right? We'll run it again just to confirm that it's that's still not dropping. It will never drop because the power limit is the long duration power limit, or PL1, is set to the same as PL2, 253 watts. But our power reading in Riva Tuner is definitely not correct. I don't think it will draw 240 watts in a game.
No, also I've never seen a power draw like that in a game.
No. To get it over 100 watts is already a challenge.
In gaming, yes. In Cinebench, not at all.
Yeah. In gaming, I mean.
Yeah.
Sorry. Yeah. But performance should be up and should stay high. You can also see the CPU clock seems to be high as well. So
Yeah, it's stable at
not sure
5.5
if Riva Tuner which core it actually looks at. For this CPU, core 2 and 3, or the P core 2 and 3, are the preferred cores. So they will boost higher if.
But this is also that is specific
available
for this CPU. It can be different for another 3900K.
Yeah, a different 3900K will have different preferred cores. So now it's 204, and it will stay this as long as you will play the game.
Yeah.
Let me check if we can find the correct power. Oh, wait, hang on. Actually, it's doing a lot of power. So maybe the first one was not correct. So it said it was doing 160. And this one is doing...
Siggy Johnson says it was on light load 16, that is why.
But yeah, this is hard to say, but... And the VGA is only doing 50. 220. Yeah, that does seem to be correct. Is it?
It's a lot of power for a game.
We haven't changed anything else, so we could change that one. Shared memory. Let me fiddle with the Riva tuner overlay.
By the way, if you guys are interested in this overlay, Ruud and Peter did a live stream where they completely explain how you can make your own overlay through MSI Afterburner and Riva Tuner. So you can actually replicate the overlay that Ruud is using right now.
Yeah, the simple one you can just download from our forum. Just look out for MSI themed Riva Tuner overlay, and then you can download it from the forum. Where is it? CPU package power.
Ruud, was there any adjustment in the light load?
No, I haven't changed it. Frame rate, no.
So the only changes you made were the long duration power limit to 253 from 125 and the ICC max from 307 to 400 amps?
Yeah. We also checked the AC and DC load line, which is basically the same as the light load mode 16.
Mm-hmm.
So that's still, yeah. Okay, let's save this one. Okay, minimize settings. I do want to confirm if the other settings are still lower if I run it with HW info in the background.
Senpai says, I did customize the overlay on my MSI laptop. Not a simple task, but fun to configure. Yeah, it is a little bit of hassle sometimes to get it how you want, but you can do quite a lot with it, and you can actually make these cool overlays with it.
That's a lot of power. This is ridiculous. Could be real. I've got about 680 watts on the wall.
Do you have F1 on there? F122?
I do have F122.
We can try to see if that one is also higher than usual.
Yeah, let's try. Yeah. But why did it show 160 before? That doesn't make sense.
Yeah, I don't know.
Yeah. Even if you increase the current limit or the power limit set to indefinitely, yeah. Oh, we have other side effects now. It's also lower, it's 197.
Yeah.
But we do have HW info in the background, but no. Let's try F122. F122.
I think soon the new F1 game will come out, right?
Yeah, it should be, yeah.
24. Usually late May, early June.
I think there were pre-orders already.
So this is a much lighter game on the CPU than what you will see from
so
Cyberpunk.
you can also do like 60 watts or 40 watts in a menu. Okay. These are the ultra settings. So this one is with ray tracing.
But being a less demanding title than Cyberpunk.
Yeah. It still does 166 watts, so that's quite a high.
Oh, this is Alonso still in an Alpine.
Yeah, that's 2 years ago. But I didn't see much of a performance difference between the Intel default and the water cooler unlimited setting in this game. So
the extra power does not result in that much extra performance.
no.
It's also not too far from the long duration power limit of the default. It's around 25 watts higher now.
Yeah, but yeah. We could also check what the power draw does with the water cooler setting. What it does in Cyberpunk, but I thought it also did like 160.
The Fall says in YouTube chat, just know I'm at 71 watts watching you both at the moment. That's how much you both mean to me. Thank you, The Fall. We appreciate it. Supreme Scorpion is saying, what profile do you prefer?
If you can run water cooler, then you can still do that. You can also tweak it if you want. If you say I want to keep my CPU cooler than certain degrees, you can set a power limit of your own.
It depends a
Doesn't
bit on
need to
what
be
you
Intel.
want as well. Do you just want the plain best performance, then unlock everything?
Yeah.
And maybe try a manual undervolt a bit so you can get higher boost frequencies under load.
You can even undervolt the default, the water cooler part. So
Yeah. But on the other hand, if you want to have better efficiency, then everything unlocked is not necessarily the best profile to use.
No, it's definitely not. No.
So, yeah, it's all a bit about your own preference. How do you want to use your PC? Do you want it to run as efficient as possible? Do you want to get the best performance? Do you want to go somewhere in between? It also matters, do you do a lot of gaming? Do you do a lot of productivity workloads? That can also change the situation a bit for you. So yeah, it is hard. What I would prefer something different in different situations. So I cannot give like one definite answer to this.
I'll go back to the BIOS and remove the PL1 and set it back to default. Doing the trick again with the DisplayPort.
Yes. So now we should get the BIOS soon.
Mm-hmm. So to get back to Intel default, it's simple. Just press F6, XMP, F10, exit.
Xockmaster is asking in YouTube chat, what are your thoughts on overclocking a 12400F through base clock?
You need a special motherboard for that.
Yeah.
So,
We actually did a live stream about this specific thing.
Yeah, the B660M mortar, right?
The Mortar Max.
Mortar Max,
Yeah,
that
because
was
that
it,
one has an external clock gen.
Yeah.
So that one can do base clock overclocking on a 14400, for example, a 14400F. And yes, you can definitely get some extra performance out of it.
Yeah.
I thought it was pretty cool actually. It was because it's quite an affordable CPU, but still, especially with a bit of base clock overclock, it can perform really well for gaming still. Xogmaster is saying, I have a Z690 board. It's the MSI board. I'm aware of the B660 though. But some of our Z690 boards also have an external clock gen. It depends on the model. The MEG models do have an external clock gen, I believe. The Mini ITX one has for sure the Z690i Unify. And I think the other Unifys, so the Unify, the Unify X, the Ace and the Godlike should also have it. I don't think any other Z690 boards have it. Do you know it? I think only MEG, right? MEG and the specific B660 models with the external clock.
Yeah, I don't know about the clock gens. No. Normally the Z you use with a K CPU mostly, so yeah.
But I know the MEGs should have it.
I think the power draw is actually correct. It already takes the top off, you know, so here you see the spike.
Yeah.
That would happen with the power limit at 253. And then it just drops down to 144 something. But yeah, once that time has expired, or there's some calculations with the power limit, so then it will drop to a hard 125. So that's definitely happening, yeah. So I think the reverb tuner power is still correct.
So it does draw a lot of power in with these settings in Cyberpunk.
Yeah, and we should be able to see the drop again, but we should also be able to see the drop in F1. But it doesn't seem to affect the performance. Yeah, there's the drop.
Yeah, there's the drop.
Yeah. Let's do F1. Yeah, otherwise it takes too much time.
The Fall says I need a new motherboard so I can have a 4090 and internal capture card. Do you have any suggestions? Well, at least make sure with a 4090, because it's a very thick card, that the PCIe slot that you want to use for the capture card has enough distance to your primary graphics card slot. So if you're, for example, using a micro ATX one, I can see the 4090, depending on the model, block so many slots that you don't have any opportunity to put the capture card in there. If you have an ATX board that has the PCI Express slot on the bottom, then you could use that for the capture card with the 4090 in a regular slot, of course. I think Tomahawk has that, right? PCIe slot on the very bottom?
Yeah, I think so, yeah. But a lot of Z790 boards have the first graphics slot.
Oh, this is on AMD, by the way, on B650.
Oh, okay, yeah.
Let me quickly check the E650.
Since F122 didn't draw that much power in the menu, it doesn't eat up anything of the power limit budget.
For the B650 Tomahawk, it depends what kind of capture card you have, because you do have a PCIe slot on the bottom, but it's a ×1. So I'm not sure what kind of interface your capture card uses. Same as for B650 Edge. Same for Carbon as well. Yeah, that's the thing with the 4090. For some models, it's such a thick card that it blocks the second ×16 full slot one.
Yeah, it also dropped to 125 now.
Yeah.
But since the 125 is close to the 150 something, you don't notice the difference in performance that much. You can also see the CPU clock drop a little bit. It used to be packed at 5.5 gigahertz. Now it's somewhere in between 5.5 and 5.2, I would say.
The 4K Elgato, I believe that one has a ×4 interface, so then the other ones wouldn't do it for you. Have a look at the Pro B650-P Wi-Fi. That one has a ×16 on the bottom. I think that is hardwired to 4 lanes, but that should be okay for your capture card. So have a look at that one. I think that should be able to do it. Yeah, as soon as the 125 watt long duration power limit kicks in, you immediately see the fluctuation a bit in the CPU frequency. Because without that 125 watt power limit, it sustained the 5.5 gigahertz. But with the 125 watt power limit, you see a little bit of drop in frequency.
Performance is actually 2 frames better than the one without the PL1 at 125.
Oh, damn.
So it was 214 before, and now it's 216. So, but I tested it, and it was so very close that there was only like 2% difference.
So it's within margin of error, basically.
Yeah, exactly. So with the Cyberpunk, the difference is much bigger, and we also see a much higher power draw for the CPU. Yeah. Actually, much higher than I expected, to be honest. So this is the Intel default, and you can play with the power limit still, without breaking the Intel default recommendation. So you just go from performance profile to extreme profile. I would definitely do that, but you can also run the water cooler and then play with the CPU light load mode or the AC load line numbers yourself.
Yeah, so Mike is also asking on Twitch chat, can you just unlimited power but undervolt the V-core? Yes, you can.
Yeah, sure. That's actually the water cooler profile.
Yeah.
Doing that for you, but you can do even more undervolt if your CPU allows it.
That's probably the way you will get maximum performance out of your CPU, by doing that.
Yeah. So I'll go to the BIOS setup, the water cooler part again, and see if we can make it crash, because what happens is
this is always the best part of live stream. See if we can make it crash.
Yeah. So the best way is just to use the CPU light load mode 1, and then it will definitely crash. But maybe we should do more gradually. I don't know, what's the time? Okay.
50 past 5.
Okay.
At least in the Netherlands, where we are located.
Yeah. Mm-hmm. But it's already at default, so that's not necessary. Just set water cooler. Okay. Yeah, that's a warning. Should it do the warning again? No, I forgot. You can set water cooler at your own risk, basically, because it's considered then overclocking. So they added that. That's good. So if you go here, it will still says mode 16. But if we would go to normal and just say I want manually mode 3. Let's do 3.
So that is very aggressive.
That's quite aggressive, yes. See if that is still, it should still boot, but depending if you load it up a lot with Cinebench or other stress test tools, then you might be able to crash it.
By the way, while this is trying to boot, we will do our next giveaway for a Steam wallet code. If you haven't participated yet, go to msi.com/2/insider, or if you're watching on Twitch or YouTube, you can also follow the direct link that our bot puts in the chat once every 5 minutes. If you have already participated, no need to do anything again, because you will still be enrolled in the next drawings as well. And our next winner, Ruud, can you read it?
Yeah, that's something in our language. Aapje.
Aapje, congratulations! You also won a Steam wallet code. Please keep an eye on your mailbox, then we'll email the code to you in the coming days with some instructions on how to redeem it. Congrats! By the way, Aapje means little monkey in Dutch.
Yeah, exactly. Okay, so no, we're set to unlimited stuff, and just checking the load line. So it's at 0.1 milliohms at the AC load line. The DC is still at 1.1, which is the default for a water cooler. And the default AC was 0.4, so we dropped already some steps there. They usually go with 0.05 milliohms steps in the BIOS.
By the way, yes, Rectaldo, we will have another drawing, don't worry. Make sure to sign up though.
So if we run, we're still quite high in the clock speed. If you start up Windows, it takes a while before everything settles and power management stuff settles, and then it will drop the clocks. So that already happened. Let's run the Cinebench thingy.
Skate says, at the root, this stuff is nerdy electronics and I love it. Yeah, so do I. I think also like undervolting stuff is really addictive because you're basically never done. There's always room to fine tune.
Yeah, but it did crash.
Oh, yeah, there we go.
Yeah. But if you look at this part, we actually matched. We undervolted it enough that it will go back from 320 watts to 255 watts, or at least something close to that. Because I think
this is not with the power limit.
No, it's unlimited.
Yeah, it's unlimited, but because of the undervolt, it got so much lower.
The voltage was dropping a lot, so it's 1.2, while the default is something 1.3 something, I don't know. But this also could happen if you have a less ideal CPU and the default water cooler setting is applied and your CPU cannot handle it, then you will have similar situation as this.
Yeah.
And it can also happen in lighter loads or in games or in between loads, you could say. And this is what's happening with the instabilities. And yes, there are a few people who have reached out and expressed their problem, but it doesn't mean that's a large percentage. There are also a lot of people who just run the water cooler default and never had any issue. I haven't seen the problem yet, so yeah, maybe we're lucky with the CPU samples we got, but yeah, it's hard to tell. It's hard to tell which percentage will fail.
Also, this is an engineering sample CPU, for example, so it may also be a little bit different than
we used to have a retail one, but it died.
Yeah. Not because of this.
Not because of overclocking or overvolting. It just stopped working. Yeah, don't know why. I can set the CPU light load to a higher mode, and then eventually it becomes stable. But there's like a gray area where it becomes stable for a while, but maybe not for the long duration. So, like Michiel already said, you need to spend a lot of time tweaking and fiddling and testing to see what is stable for your system. So that's trial and error. That takes a long time.
But that's also kind of the fun of it, I think.
Yeah, it is. Yeah. That's tweaking. I can show you what CEP does to the water cooling settings if it's in the default AC DC load line stuff. If we can go to the BIOS, or are we crashing completely? No, it's still responding.
Skate says, undervolting and overclocking are when the CPU becomes yours. Yeah, I can see that. You almost get like an emotional attachment to your CPU. But at least that's where you get to know your CPU for sure, because you learn the limits of your specific CPU.
But only do it when you have a lot of time and no critical things on your system.
I did put quite a lot of time in finding the sweet spot for my curve optimizer negative offset. but I still have a single negative offset over all cores. So I could even go further and set specifically fine-tune it per core, but that takes so much time. And then I only have a 6-core CPU. Just imagine if you have a 16-core, for example, and you want to do the per core negative offset. Then you have to test stability for every single change you make. And if at a certain point it becomes unstable, then you're not even 100% sure it was your last change or it was something you did previously.
Yeah. It gets complicated quickly.
CID 337 says 16-core curve optimizer is a nightmare, which is what I do. Yeah, if you do it specifically for every core, that is really time consuming. I can imagine it is a lot of fun though, but it can also be really frustrating.
So I set the AC and DC load line to the default ones for the water cooler profile.
Mm-hmm.
Now let's find where the CEP is. It's right here, but hard to see. So CEP should be enabled. The default is disabled for water cooler, and that will show should show the phantom throttling. So power's still quite high, clocks are high, but performance is low, or much lower than it is without the CEP enabled.
Simi86 says in Twitch chat, or you lose the emotional attachment really fast. Yeah, if you do get annoyed by it, then don't bother. Xogmaster says in YouTube chat, have you guys toyed around with the CS2 FPS benchmark workshop map? Have you, dude?
No, not
I
yet.
haven't yet.
No, I didn't know it existed. I was trying to get Counter-Strike 2 to run the same as CSGO before.
Because you used to benchmark CSGO with like a fixed demo file, right?
Yeah, you can record like your own game and then play it back in CSGO, but that seemed to be broken with CS2. I don't know, there's probably a lot of updates now and they probably fixed it. It also worked a little bit differently with CS2, but we'll have a look at it. Always interesting to use that as a benchmark. Let's double check if the AC and DC load line are still correct.
Submaster says the CS2 FPS benchmark workshop map auto runs you through with no user interaction. It's a good benchmark set.
Okay, yeah. So the AC load line and DC load line are set correctly. I checked it because the CEP enabled setting. If you're just running water cooler and enable CEP, then it automatically changes the CPU light load not to 16 but to I think 13. It's 0.8 and 1.1 milliohms. And why it does that? Because then the phantom throttling doesn't happen, but I wanted to show you the phantom throttling does happen. So here we try to run it. Okay, the clocks are already lowered. And then we should see that.
So here you will not see it in the power draw, you will not see it in the frequencies.
The power draw is still high, but not extremely high, because in water cooler it would run at 320 watts.
Mm-hmm.
But the peak core clocks are 5.5 and the E-clock cores are 4.3. The only thing you can see that it's actually doing some throttling is that the effective core clock of the E-cores are much lower than it's supposed to be. This also should be 4 point something.
Basically half.
Usually it should be 4.3, the same as the normal clock. But that's the only thing you can see if you pay attention to it and you know where to look for it. But the performance is 18 instead of 40. That's more than half, or less than half, so it dropped more than half. So yeah, that's quite a big gap. And also on the wall there's quite a bit of power drawn. So where does the power go? At least not to the performance.
This is basically what you could reach with like an 8-core part like the 7700X or something, right? In terms of score.
So that
So that's a big performance hit for a CPU with so many cores.
So with CEP enabled and the AC/DC load line undervolt trick, you could run into a phantom throttling situation, and then you need to raise at least the AC load line. But
at least you will very easily see this in your Cinebench scores.
Yeah. If you check performance, then you will see it. But if you check only clocks and if it's running, then you will not notice it.
Yeah, then you may think it runs fine, but it actually doesn't.
Yeah. That was just something I discovered. I just wanted to show you, and also read about it, and I could definitely reproduce that error. Is there something else we?
Yeah, because there is the new 3D Mark version.
Yeah.
Let's maybe have a look at that.
Yeah,
so this was launched, I believe, yesterday.
Yeah, let me undo the settings.
Let's go back to more normal settings.
Yeah, we can do just the Intel settings or the water cooler settings. Both are good.
The fall is saying, I'm too afraid to mess with my 7800 X3D and set off the smoke alarms. Well, actually, I don't think you have to be too worried about that, because, for example, if you apply curve optimizer through PBO and set a negative offset, you will not burn it, because you will actually lower the voltage that you put through your CPU. The biggest risk you will have is that it will become unstable, but you can solve that by raising it again. So yeah, if you like fiddling around with hardware, then I would definitely recommend. I think AMD Curve Optimizer is a very accessible way to undervolt the CPU and get more performance out of it. So personally, I really like that tool, and I would definitely recommend to fiddle around with it a bit and see if it can work for you as well. And usually the 7800 X3D, at least most from what I heard, you can undervolt quite a bit. I've heard multiple people that had a -20, -30 negative offset on it. And how far yours can go, of course, very much depends on the silicon lottery. Okay, back in Windows.
Back in Windows. Checking limits. Selected water cooler and XMP. That's the only thing I did. Let's see. Okay, unlimited. That's all right. Unlimited ACC max. Yes, and there should be 0.4, 1.1. Also check. Yeah. Everything set correctly.
All good.
Or maximized, or MSI optimized. That's how you call it.
So this new 3D Mark version, it's a Steel Nomad one. So it was launched yesterday, and this is actually, at least in the future, this is meant to be cross-platform. So right now, I think it only launched for x86 systems. So now you can run it on, for example, a Windows system like this. But I believe in the future, it will also be for ARM-based systems. I believe it will support Linux, macOS, and eventually there will also be like a light version that will support mobile, so Android, iOS, those kind of things.
I'll just run it, yeah.
So that you can also compare performance between different platforms.
Yeah, this is the Steel Nomad Lite, so this is the 1440p benchmark.
Yeah, so you have the regular Steel Nomad test, that's Ultra HD resolution, so 2160p, and a light one indeed, 1440p.
Yeah, we're probably going to see this benchmark a lot in our office.
Yeah, so you can already get used to it a bit.
Yeah.
But how many times do you actually watch it? I think most of the time you
just run
start
it
and
wait for it to finish.
And
usually
do something else.
Usually we script it, so we don't really need to record anything. We just save the file and we'll see the results later.
Yeah. It does look pretty though, this benchmark. So yeah, this should be available now. You can also test it at home on your PC if you want.
Yeah.
PC Games Hardware, media from Germany. They already tested a lot of graphics cards with this new benchmark. So later on we'll also show you some of those results.
Yeah, so it's 43,755.
So this is an RTX 4090.
Yeah.
I actually have the PC Games Hardware results on my right, and they also use a 4090 with an i9 3900 KS. So that's actually very close to what we're using now. We're using not the KS but the K.
Yeah.
Let me pull the results up, because this is 43,755 and they're at 43,197. So that's very close.
Yeah.
Strange enough, we even outperformed it a little bit.
Yeah, I don't know why. Maybe different driver or.
Yeah, could be. I don't know what they were running in the background still. Or, but here you see a little bit of a comparison between different graphics cards, recent graphics cards. So 4090 is the one that we were using as well. But these are also other recent cards from NVIDIA, AMD, Intel as well. So on the next page there are a couple more. And it shows the results for the light test 1440p in orange, and the Ultra HD one, the 2160p in yellow. So that's the non-light one. I think it's just called Steel Nomad, and the other is Steel Nomad Light. Sid337 is asking, is that the new 3D bench? Yeah, 3D Mark bench? Yeah, it is. It launched yesterday. These are just 18 of the recent cards that they tested with it, but the PC Games Hardware test is more extensive than this, so you can definitely check out their website. They also tested a bunch of older cards. So for example, 6000 series AMD, 2000 series, and even 1000 series NVIDIA. Some older Intel GPUs as well, 300 series. So you can check their website and you can see how they fare against each other. Anything else you guys want to see or are curious about? Otherwise, we will do our last drawing before we close it up for tonight.
I see a comment about someone who's complaining about the G77. It's running at 95 degrees centigrade. I assume you're talking about the CPU. The CPU is quite warm. Any Intel CPU, mobile or not, they will run to the thermal limit. And for most notebooks, that's set at 95 degrees. So if you're pushing it, then yeah, it will run at 95 C. That's normal. But it also means you will get the most performance out of it.
Yeah, so that's just the set limit, and it will basically max out performance until it reaches that set limit.
Yeah, yeah. You could lower it by setting probably silent mode, but yeah, your performance will be less. Yeah.
JCB says, sorry I was late, but I'll try to be more punctual. You better be. But luckily you can still watch the full live stream back on demand.
Yeah, you can watch it back.
That's very good. Then let's go to our last drawing. Next week, we're still figuring out what we'll do next week.
Okay.
We do have some ideas for topics, but not confirmed yet. At least what we do know for sure is that we will be here again. Same place, same time. And then we will draw our last winner for a Steam Wallet code. Ruud, the honor is all yours.
Grodderp, I would say.
Grodderp, congratulations.
Grodderp.
You also won a Steam Wallet
Congrats.
code. So congrats again to all winners. Please keep an eye on your mailbox. We'll email the Steam codes to you in the coming days with some instructions on how to redeem it. So next week we will be back, of course, with another giveaway. Thank you so much for joining today. I hope you learned something. I hope you enjoyed it. And hopefully see you next week again. Thank you and goodbye.
Thank you. Goodbye.